Hey Stats class, in this video we're going to look at how to find critical values for t-test, hypothesis test about a mean with a standard deviation, population deviation unknown. So to do these we need something called the inverse t distribution. So it is second vars, right there number 4 is inverse t. Alright, and it says determine the critical values for right-tailed test at the alpha equals 0.1% level significance with 15 degrees of freedom. So this is a right-tailed test. So that means that we're anticipating, that there's the middle of the distribution at 0, that we think we're going to be in the right tail. So this area right here represents the alpha, the level of significance. So it's 0.1 in this case, and it's in the right tail. All right, now when I do this inverse t, I need the area in the left tail. And so if the area in the right tail is 0.1, the area in the left tail is 0.9. So I'm looking for this number, this critical t value, that has an area to the left of it of 0.9. And then the degrees of freedom, it also needs to go in there. So 15 degrees of freedom. So 0.9 for the area, and then 15 degrees of freedom. And then when I plug that in there, I get this number, which is a positive number, and that's 1.341 to 3 decimal places. Alright, so right tail tests are going to have positive t critical values. Left tail tests are going to have negative ones. Alright, now we have a left tail test, so there's 0. We think we're going to be in the left tail, and alpha is 0.05. That's our alpha. That's the area of that tail. We're looking for the t critical value that has an area of 0.05 to the left of it based on the sample size of 10. Alright, if sample size is 10, that means the degrees of freedom is 1 less than that. So my area in the left tail this time is going to be 0.05 with 9 degrees of freedom. So second vars, inverse t, area to the left is 0.05. The degrees of freedom is 1 less than 10, which is 9. So there's my setup. I get a negative number this time. Negative. You've already put the negative in right there, so now you're just putting the number in. 3 places, 1.833. Alright, be careful not to put a double negative in there. I have students do it all the time. Alright, now look at this final one. Determine the critical values for a two-tailed test. Alpha equals 0.1 level of significance. So we got to remember here, a two-tailed test means alpha gets split in half. So half of that 0.1 goes down below, and that'd be 0.05, and half of it is in the upper tail, 0.05. So there's a drawing of our setup where we think alpha is going to go. It could be above or below in a two-tailed test, and we divide it in half. Alright, sample size again is 18, so that means degrees of freedom is going to be 1 less than that, 17. Alright, so I'm going to use inverse t. I'm going to get this number down on the bottom. It's going to give me the lower value. But because the mean is 0 of the t distribution, then that means this upper value is going to be the opposite of that number. So this is going to be a plus minus. So I'm going to select down here plus minus. I'm going to do again inverse t, so second vars, inverse t, not norm, inverse t. Right, the area again, it's half of that 0.1. So 0.1 divided by 2 is 0.05. You could also just do 0.1 divided by 2. If you do that in there, it'll calculate it for you. The degrees of freedom is 18 minus 1, so that's 17. Paste it in there. So plus and minus again. We've already put a plus and minus. We don't need that negative. So 1.73. Next number is 96. So we round that up. That'll round that to a 4. So 1.740. Alright, just be careful with your rounding. Be careful with those negative signs. If you're getting a negative number from the TI and you got a plus, minus, or just a minus, you don't need to put it in there a second time.